So on the last day, regarding the renewable energy and non-conventional energy subject, we have discussed about the non-renewable sources like nuclear power. Then we have discussed the types: nuclear, oil, natural gas, and coal. Okay. This one we have discussed. Coal, petroleum, and gas. This introduction we have discussed. Fossil fuel, how it can be made, coal. Okay. And how coal is prepared, that we have given a brief introduction regarding this. And then the coal formation processes. And what is the different disadvantage of the coal? That when the coal is burned, it produces the carbon dioxide that causes the global warming. Okay. And since coal contains the impurities like sulfur and nitrogen, okay, it produces toxic gases during the burning, which causes acid rain and air pollution. And traces of the mercury and radioactive compounds are also released when coal is burned. It causes a severe human health threat like lung disease. Okay. Now, oil and natural gas. Oil and natural gas. Now, India has about 0.04% of the 0.04% of the world's proven reserve of the hydrocarbons. The Hello, am I audible?
Yes, sir.
The prognosticated geological resources of carbon in country are 21.31 billion ton, of which 61% are offshore and 39% on land. Now, crude oil is made of many different components, like each with its specific boiling point. Using distillation, we are able to separate. Actually, I having the mouth ulcer. Okay, so that's why I'm not able to talk properly. Crude oil is made of many different compounds, each with its sulfur specific boiling point. Using distillation, we are able to separate out these compounds and turn them into commercial products ranging from gases to asphalt. Now, one thing I just want to show you first. Now, see here, regarding the installed capacity of the coal, okay, that is non-renewable. Okay, non-renewable. You see, for the coal, it is 205.1 in gigawatt, the unit in gigawatt. See, following table has breakdown of existing installed capacity in March 2020 from all sources. Okay, and since 2019, the hydropower generated by the under Ministry of Power is also counted towards the Ministry of New and Renewable Energy. Okay. So renewable energy purchase obligation targets under which the distribution company, okay, of the various states have to source a certain percentage of their power from renewable energy source under two categories: solar and non-solar. Now see that under non-renewable, that is coal, having 205.1 gigawatt installed capacity, whereas in gas, say petroleum gases, okay, natural gases, that is 25 gigawatt capacity, and diesel, that is petroleum, we have 0.5 gigawatt of capacity. Okay, so totally we have 230.6 gigawatt. Now, whenever we consider about the renewable, we see the nuclear having 6.7, large hydro having 45.7 gigawatt, small hydropower having 4.7 gigawatt, solar power having 38.8 gigawatt, wind power having 38.7 gigawatt, biomass power having 0.2 gigawatt, waste to power is 0.2 gigawatt, and separately from renewable we have 135 gigawatt. So from both non-renewable and renewable, we have totally 365.6 gigawatt installed capacity. Okay. Now another thing you see, that is off-grid renewable energy installed capacity as per 31st July 2019. Okay, that is off-grid. You see, this is the source and the total installed capacity. That is SPV systems having 0.94 gigawatt, biomass gasifier that is 0.17 gigawatt, waste to energy is 0.19 gigawatt, and total is 1.20 gigawatt. Okay. So the petroleum gas obtained during the cracking and fractional distillation can be easily converted into liquid under high pressure, okay, as LPG. Natural gas is found above the oil in oil well, okay, oil well, okay, oil well, where you have to dig it and you have to find out the crude oil, okay. It is the mixture of 50 to 90% methane and small amount of other hydrocarbons. If the natural gas contains lower hydrocarbon like methane and ethane, it is called dry gas. So this is the definition is directly I have mentioned here, that if the natural gas contains lower hydrocarbons like methane and ethane, it is called dry gas. If the natural gas contains higher hydrocarbon like propane and butane, okay, if the natural gas contains higher hydrocarbon like propane and butane, it is called wet gas. Next you have petroleum. Now petroleum or crude oil is naturally occurring flammable liquid consisting of a complex mixture of hydrocarbons with small amount of sulfur oxide nitrous of various molecular weights and other organic compounds, okay, that is found in geological formation beneath the earth surfaces. So the petroleum or crude oil is naturally occurring this flammable liquid consisting of a complex mixture of hydrocarbons with a small amount of this of various molecular weights and other organic compounds that is found in geological formation beneath the Earth's surface. Now, how are the oil and gas made? Now you see, this is the particularly ocean. Okay, so in 300 to 400 million year ago, this kind of components, that particular oils that is made from this particular uh, animals, okay, so these tiny sea plants and animals died. The tiny sea plants and animals died and were buried on the ocean floor. Over time they were covered by average of still slit and sand, okay, and about 50 to 100 million years ago, 150 to 100 million years ago, okay, the remains were buried deeper and deeper. The enormous heat and pressure turned them into oil and gas. Okay, so from these particular animals, sea plants and animals, we are getting the oil and gas. And you see, these are the like ONGC station. Okay, and this is the and slit rock, and this is the deposit of oil and gas. Okay, so today we drill down through layers of sand, slits, and rock to reach the rock formation of and that contain oil and gas deposits. Okay, now this is the typical oil refinery process. Okay, typical oil refinery process, and you see from the furnace when it heated, basically the crude oil. Okay, the crude oil is here. So whatever the oils, basically we are drilling down from the particular we are drilling down from the particular sand and slit. Okay, the layer of sand and slit and rock, we are basically finding the oils. Okay, oil and gas deposit. And see, when we heat the crude oil, okay, when we heat the crude oil, sometimes we are getting the diesel oil, then we are getting the heating oil, we are getting the aviation fuel, then we are getting the gasoline, and then we are getting the gases. So there are different segments are there for finding the different stages. Now, what are the advantages of natural gas and disadvantages of the natural gases? Okay, now natural gases that having ample supplies are there, high net energy yield, low cost, okay, with huge subsidies, less air pollution than other fossil fuel, lower carbon dioxide emission than other fossil fuel, moderate environmental impact, easy transported by pipeline, okay, low land use, and this is good fuel for fuel cell and gas turbines. So there is a topic is there, that is fuel cell. So this is used for this is good for fuel cell and gas turbines. And what are the disadvantages of natural gas? That is, it released carbon dioxide when burned, and methane. That is called methane. That is called green. It is also called a greenhouse gas. Can leak from the pipeline and shipped. Can be shipped across ocean as high explosive LNG. Okay, and sometimes burned off and wasted at wells because of low price. Okay, so advantages are the available advantages of this particular non-conventional sources. Okay, so what are the advantages of these non-conventional sources? That is, it's available in high concentrated form. Okay, because when it's required, you can directly go and purchase. So available in highly concentrated form, but uh, after a time it will end. And I have told you that whenever there will be availability, okay, from the animal and plant offshore, you will get it. You can drill it and you can get it, but it depends on the whatever our storage are there from the years to years. Okay, so available in high concentrated form, it is easy to store, reliable supply, lower cost per unit of energy produced as the technology is matured. Okay, and disadvantage is what, the it is highly polluting. Okay, available only in few places, high running cost, limited supply, and will one day get exhausted, executed, exhausted. Now, how does we use it? Now you see, whatever the renewable energy and whatever the non-renewable sources of energy like fossil fuel, gas, petroleums. Okay, so we are using in the different stabilizers, different UPS inverters, cable setup box. Say like equipment like 0 watt bulb. 0 watt bulb, that is basically consumes 12 watt. Okay, sometimes it is 6 watt, sometimes it is 12 watt as per the design manufacturing of the industry. Okay, so 12 watt. Then mosquito repellents, so it is 10 watt. Mobile chargers, that is 5 watt. Voltage stabilizer 25 watt. And UPS inverter, it is 40 watt. And cable setup box, it is 25 watt. Equipment running in standby mode. Equipment which is running in standby mode. Okay, this is the power consumption in watt. So compact audio system consumes 27 watt. DVD, CD, VCD player, they are consuming 12 watt. Microwave oven consuming 6 watt. Inkjet printer consuming 5 watt. TV consuming 22 watt. Now, the Asian energy sources released. Asian energy. Okay. The Asian energy sources released 1256.4 million metric ton of methane. This is actually as per the old record. Okay. No, I could not find a new record. What is the new record now? If I could find that thing, I will send it to you. Okay. So Asian energy sources released that 1256.4 million metric ton of methane, 3222 3,228,000 metric ton of nitrous oxide. Okay. 1,221 million metric ton of carbon dioxide, 1,242.4 million metric ton of carbon dioxide equivalent of hydrofluorocarbons. Okay, perfluorocarbons and sulfur hexafluoride. Now, why to conserve? Conserve is basically terms of energy conservation. Okay, there is a difference. There is some differences there between the energy conservation, okay, energy conservation and conversion of energy, energy conservation and conversion of energy. So why to conserve? We have limited fuel available on earth. Okay, we have limited fuel available on earth, and our demand for energy is increasing day by day, because day by day population is increases. So if the population is increases, then automatically the number of households automatically increases. Then automatically the demands of jobs, the demands of working principles, demands of working networks are increased. Okay, so it is possible that someday most of fuel will be exhausted and we'll have to switch over to alternate energy. Now, why energy efficiency? Why energy efficiency? So basically the countries which are facing power storage, that is peak storage is 13%, average storage is 8%. Okay. So peak storage is 13% and average storage is 8%. And additional power required by 2012 is 1 lakh megawatt. Okay. Approximately. So in the year 2012, there is an investment of 8 lakh crore in investments. So India's energy intensive for unit of GDP is higher by 3.7 times of Japan, 1.48 times of Asia, and 1.5 times of USA. So higher wastage of energy and very high energy saving potential. The energy solution, no cost. Energy item, that is lightning. Okay, lighting. So lights off when not in use, and use day lighting. Okay, so it having a savings of 80 to 20% of the lighting energy. Heating and air conditioning. So if we set the thermostat at low as possible, if we set the thermostat as low as possible, now you see heating and air conditioning. Now heating and air conditioning. Now if I simply tell about the refrigerator, if I simply tell about the simply about the refrigerator, okay. So suppose if in your refrigerator there are very less number of foods are there, very less quantity of foods are kept in the refrigerator, then you can, I'm not talking about the deep fridge, but in the lower side, if it is a double door, you can maintain the speed in low position. Okay. So set the thermostat as low as possible. For each degree, up to 5% will be saving. Then heating, ventilation, and air conditioning. Okay, limit after school activities to as few heating and cooling zones as possible. That means actually in the working sectors, say if all times we are keep switching on the ACs, then automatically there is a huge loss of the energy. So it is better to do not use the air conditions when not required. Okay. So in that case, up to 25% of the heating cooling cost will be saved. Heating, ventilation, and air conditioning. Do not back airflow to HVAC vents. Okay. Do not block. Do not block airflow to HVAC vents. So do not block airflow in HVAC vents, because whatever the vents are there, that is collecting the hot air, so if that particular, the dust is there, if we do not clear in time to time, then in that case what is happening, the efficiency will be coming down. Okay. So if and the if we clean at every time, so in that case up to 10% of the heating cooling cost will be reduced. Okay. So heating, ventilation, air conditioning, they keep doors and windows closed while HVAC runs. So if your door is closed, windows are closed, then automatically it will take lesser time to make cooling of the room. So in that case, 1 to 25% of the conditioning energy uses will be saved. And office equipment, say turn off the machines when not in use. When suppose you office is over and you going back to home and keeping the all the lights, fans are on, so in that case it is a wastage of energy. So if you switch off in proper timing, in that case you can able to save 10% of the energy bill. Acha. Now for lightning again, if you replace the incandescent bulbs with compact fluorescents, incandescent lamps with compact fluorescent. Another is nowadays what we are considering the LEDs. Okay. So if you can also replace the compact fluorescent lamp with LEDs also, in that case, so you can able to save another 5% of the energy. Okay, so if you to replace fluorescent, if you replace incandescent lamp with a compact fluorescent lamp, in that case you can able to save 50% of the energy. Additionally, if you implement the LED by replacing the uh, replacing the compact fluorescent lamp, in that case you can save another 5% to 10% of energy. Okay, so use more task lighting and less overload. So less overload means when there is a not required of illumination, direct illumination, brightness illumination. So in that case there is no need to point of full amount of lights. Okay, so in that case you can able to save 25 to 50% of the lighting energy. Okay, now heating, ventilation and air conditioning. Now in that this case, if you perform schedule maintenance. So schedule maintenance means every year there will be a servicing. So if you go for the servicing properly, in that case you can able to manage up to 10% of the energy. Okay, up to 10% of the energy you can able to manage. Okay, now looking now heating, ventilation and installation. So in install looking converts on
क्या हो गया भाई?
पता नहीं. हेलो
सर तो डिस्कनेक्ट हो गया.
हाँ सर, तो नेटवर्क गया होगा.
तब तक बोलो सचिन कुछ पढ़ा देगा अपना स्क्रीन शेयर करके.
So install locking covers on thermostats. Okay, by this way you can able to save 10% of the energy. By student energy, by selecting the student energy team to monitor. So if there is certain students using for monitoring purpose, so in that case, basically this is applicable in the outer states, for the foreign states. Okay, energy team to monitor. In that case, you can able to save the 15% of the total facility energy uses. Okay, Now for the lighting, okay, replace T12 fixtures with T8 and electronic ballast. So T12 and T8, this is a one kind of chip is there which is required for ballasting purpose in the lamps. Okay, so if you do that thing, in that case you are able to save 20 to 30% of the lighting energy. So actually the proper voltage is required to provide the flow of ions from anode to cathode. Okay, so that particular process, when you get the illumination of lighting, so by changing that particular ICs, you can able to save 20 to 30% of the lighting energy. Now replace mercury vapor fixture in gyms or outdoors with halide metal halide lamp, high pressure sodium or T8 or T5 high output fluorescence. So in that case, you can able to save 10% of the energy. Why we are doing this? Because you know that whenever we are considering the term of fossil fuel, right? Fossil fuel, coal. In that case, directly you are getting the electricity in large amount. Okay, but you know that day by day you have to depend on the day by day in the coming days you have to fully depend on the renewable energy sources. Now in India, not only in India, in the whole world, you're not able to we are not capable to generate or not able to install the power in a large scenario. Okay, so in that case we also have to go in certain way, so that by replacing some kinds of lamps you can you can save some energy. Okay, then install occupancy sensor. By installing the occupancy sensor, you can able to save 20% of the lighting energy. Install Energy Star leveled programmable thermostat. So you already seen that in some of the refrigerators, air conditioners, the star marking has been already there. So in that case, you see that when you go to the market, basically when you go to the market and you are seeing that it is a 4-star machine, it is a 5-star machine. So if you purchase a 5-star machine, then automatically you will see that in that particular machine it consumes less energy. Okay, so this is all about this Energy Star. Energy Star. So Energy Star products meet strict energy efficiency standard set by US EPA and US Department of Energy. Okay, in 2005, the US saved enough energy to avoid greenhouse gas emission equivalent to those from 23 million cars. Please come after 15 minutes. Cars, okay. Now it is saved $12 billion, or utility bills help avoid 28,000 megawatt of peak power. So your this chapter, the introduction chapter, is actually consist of these things. Okay, and by tomorrow I'll put this thing in your ERP portal. Okay,